It just amazes me that this camera head drifts. I just don't understand that. Hi. Well, so this is assignment 53. And I don't know if any of you are going to watch this. It's question day on the assignment calendar. But I thought, if you wanted some extra problems, I got some extra problems for you that we could talk about and that you could try and do. I definitely think you should spend some time engaging with all those worksheet problems. And like I've been saying for much of the year, you probably need more practice than you think you do. And so I recommend that you do these problems. Okay, so head south 20 degrees east for 10 kilometers, then turn north 70 degrees east for 2 kilometers. And, tell me those things that we like to know. How far to get home and on what bearing. Okay, so let's draw. South 20 east. Degrees east, and I'm going 10 kilometers. And when I get there, 10 kilometers. When I get there, I'm going to go north 70 east, but only for 2 kilometers. And 70 degrees. And this is the trip back home. There's a right angle here. Okay, so I'm looking at this triangle. 2, 10. This angle is 80. Is it 80? No, it's 20. This south, 20, 20 east. So that's 20. Great. So I guess that's 20. Oh, and 20 plus 70. Good. I like that being 90. And this is 70. So this one over here must be 20. Okay. It's a right angle. I feel like I need another piece of information. I mean, not to find the distance home. That's just Pythagorean theorem, square root of 104, which I guess is 221, 2 root 21. And you can decimalize that on your calculator. Here's part A. Yeah, because 10 squared is 100, and 2 squared is 4, 100 plus 4, and take the square root. That's where that came from. But what about on what bearing? Well, let's draw compass rose there. I find drawing the compass rose to be really, really helpful. For one, because I see parallel lines cut by transversals, but also because when I draw my compass rose, I see that that's my bearing home. Now, what do I know? Well, if that's 70, that's 20. And because these lines are parallel, and there's my transversal, that little bit there where that dot is, that's also dot equals 20 degrees. Okay, if only I knew how big that was. I could add those two dots together to get that whole angle. Okay, well, let's see what we can do about that. This angle I can find with tangent. Tangent theta is 2 over 10. So theta will be tangent inverse of 2 over 10 or 1/5. Okay, so what do I get? Inverse tangent of 1/5. And I get that theta equals 11.30993247 degrees. Cool, but how does that help? Well, we know that this angle is 20, and therefore all of this is going to be 20 plus 11.3099. So I know that that big angle is 31.3099. I guess I can say 31.10 degrees. Now, why is that interesting to me? Well, there's my transversal, and here are my parallel lines. And so this angle and this angle are the same. And that's my bearing angle. Woohoo! So I can write my bearing as north 31.31 degrees west is my bearing home. Yeah, there's a lot of stuff going on here, huh? Did I need that? Only to confirm that this was a right angle. So that I needed. That I found with inverse tangent. These two angles added together, because of alternate interior angles, are the same as this one. And that's my bearing if I go north, something west. Okay. Maybe we should do another one of those. Yeah, I think so too. South 40 degrees west for 5 miles, and then south 50 degrees east for 20 miles. And let's just do the bearing part here. On what bearing will we need to go? Okay, so let's go south 40 west, heading south, and then 40 degrees west for 5 miles. And we stop, and we turn, and we go south 50 degrees east, and we go for 20 miles. This should be 4 times as long as that. And we get to here, and we want to go home again. We would use the Pythagorean theorem to find that distance back. How do I know that? Well, that's 40 degrees, so that's 50 degrees. And there's a right angle, so 90 minus 50 is 40, and 50 plus 40 gives me a right angle there. Yep, Pythagorean theorem. Okay, but I'm much more interested to know on what bearing do I need to go to get home. I'm going to head north and then something west. Okay, north, something west. Well, let's find out. This is the angle I want to find. And what do I know? Well, I know that I've got this side and this side. So, well, I guess I could do this a couple of ways. So I could pretty easily find theta using tangent with opposite and adjacent. But that's not my bearing angle. So yeah, I can find that, and I could do something with it to help me find the bearing angle. That's not too hard. Well, let's just do that. We'll start with that, and if the spirit moves, then I'll try a second approach to the problem. Okay. So I'm going to say the tangent of theta is 5 over 20. And if I take the inverse tangent to both sides, I get theta equals tangent inverse. 5 over 20 is 1/4, so 0.25. Okay, inverse tangent, 0.25, and I get theta equals 14.03624,347 degrees. Cool, now I know that. And how does that get me a bearing angle? Hold that thought a moment. Because here I see parallel lines cut by a transversal, and so I know that alternate interior angles are equal. If this is 50 degrees, this is 50 degrees. Well, see this 50? It contains both our bearing angle and the theta we just found. So if I do 50 minus this theta, I'll be left with my bearing angle. Oh, okay, so 50 minus theta. And I get 35.964 degrees. Oh, that's very nice. I was also thinking of doing this problem where I extend the compass roses to make right triangles. So this would be 40. And if I take my 40 plus my 14, 40 plus the 14 at 54 degrees, and a little bit more because this was decimal. But look, there's a right angle here, and so if this one and this one are known, I can subtract these two from 90 to get this missing one. So 90 minus 40, that was the angles to make a triangle 40, plus that 14.03624 number. Sorry, subtracting that as well. And then what am I left with? I'm left with 35.964 degrees. So yeah, I can get that bearing angle a couple of different ways. In fact, this 54 one, this thing here, this 4 minus 40 minus 14.03, if I wanted to say head west and then a certain amount north, that would be this 54.036 north. So west 54.036 north would be an alternate correct answer there. Okay. Wow, I got lots more bearing problems. But I think I want to do a couple of these two triangle problems. Ooh, and maybe an angular and linear velocity. Oh, look, we've got all kinds of regular polygon problems. Oh, and draw and write the equation of the given triangle. I'm sorry, the given sine function. Wow, there's a lot of things for us to take a look at. I better get a move on. So we have bearing. Now let's move on. Find the area within a regular dodecahedron whose side length is 10 centimeters. Okay? I think we should give that one a try. I mean, the assessment is coming up in a day, and maybe 2 at the most, and you know this is going to be on it. So surely you've been practicing. I know we've done 3 or 4 of these in videos already. So, oh, is this what's stopping you? Deca 10, do plus 2. This is n equals 12. Okay, we've got a 12-sided figure here, and I'd like to know the area. Not the thing. Okay, side is 10, so that would be 5 centimeters. Okay, pause the video, give it a try, come back when you're done. All right, well, remember that we have a formula for phi, which is 180 over n, where n is the number of sides. Or we could find theta, and our recipe for theta is n minus 2 times 180 over 2n. Why over 2n and not just n? Well, this is really what I'm finding with this formula, but I don't want that whole angle. These pieces are congruent. I've been cutting them in half with this, so I'm going to, cut that amount in half. Okay, and what do we get for a dodecagon? 180 over 12 is 15. Yep, 15. So I know that this is 15 degrees. Opposite and adjacent, so I guess the tangent of 15 is going to be 5 over apothem. I'll multiply both sides by apothem, and then divide both sides by 10, 15. I get apothem equals 5 over 10, 15. Apothem. Okay, so 5 divided by tangent 15 would help if the calculator was on. 10, 15. And I get that the apothem is 18.66025404 centimeters. Cool. Does that mean I'm done? No. Remember the formula for area is 1/2 perimeter times apothem, or apothem. Well, my perimeter, I know the side length is 10. I know there are 12 sides. So perimeter is 10 times 12, or 120. And therefore the area in this problem is going to be 1/2, 120 times 18.66025404. So that's 1/2 of 120 is 60. And we have 60 times our apothem, and I get that the area is 111.9.615 centimeters squared. That's a bunch of square centimeters. Cool. Oh, I just looked at the notes, and the problem didn't say side length of 10. It said whose radius is 10. So let me erase this, and you can recalculate. So here's our apothem, and here's our radius of 10. X is half the side length, so keep that in mind. There would be an X here and an X here, but really I'm aiming for 1. And these angles, well, they didn't change. This is still 15 degrees. This is still 75 degrees. Okay, so how are you going to do it? Why don't you pause the video, give it a try. Don't want you to be surprised if this happens to you on a test or a quest. Cross between a quiz and a test. Okay, are you back? So let's say I want to find x. I have opposite and hypotenuse. The sine of 15 degrees is x over 10. So x will be 10 sine 15. Cool. What about the apothem? Well, apothem is adjacent to that, and I know the hypotenuse. So cosine 15 is apothem over 10, and therefore the apothem is going to be 10 cosine 15. Excellent. And the formula for area, 1/2 perimeter times apothem. Well, what about the perimeter? Is this the perimeter? No. I have to double that amount to get a side length. And then I've got to multiply the side length by how many sides I've got. So 2x is a side length, and then I want to multiply those sides by 12. So 12s is p, and so I want 12 times this, 24x. So I need to take this and multiply it by 24, by 1/2, by the apothem. So 24 times 10 sine 15, good, times 10 cosine 15. And don't forget, we need the 1/2 out in front. So times 1/2. I get exactly 300 square centimeters. That seems so amazingly unexpected. Like, did I type that in right? Kind of unexpected. So x times 24. 24, 10 sine 15, yeah. 10 cosine 15, yeah. And times the 1/2. Yeah, okay. So 300 it is. Good. So we've done 2 more of those now. How about 2 triangle problems? Okay. We know that this is 12, this is x, this is 10 degrees, and this is 30 degrees, and we want to know that height. Okay, give it a try, see how it goes. Hey, welcome back. Did you split this into 2 triangles? I hope so. Here's one of them. We have x and h and 30. And this one, we have h, we have 10. And this side is this whole thing. It's x plus 12, not x times 12. X plus 12. Okay. And if you got this far, but couldn't go the rest of the way, or I mean you were stuck trying to get to this place, if you think you can, now pause the video again and see if you can go from here. So this is tangent 30 equals h over x. And here we have tangent 10 equals h over x plus 12. Okay, if I multiply both sides here by x, I get that h is x times 30. And if I multiply over here by x plus 12 on both sides, I get h equals x plus 12 all times tangent of 10. Well, look, both of these equations are now solved for h, so I can set this stuff equal to this stuff. What will I have then? I'll have x tan 10 plus 12 tan 10 equals x tan 30. Oh, what did I do here? I distributed the tan 10 to each of these. Okay. We've got x's on both sides, so I think I'm going to move these over here. That'll give me 12 tan 10 equals x tan 30 minus x tan 10. Well, I see I can factor out an x from each of those, leaving me tan 30 minus tan 10. So if I divide both sides by this stuff, I'm going to get what x is. Tan 30 minus tan 10. Please be careful with your parentheses. Everything in the denominator has to be in parentheses. If you don't, then the calculator thinks you're dividing 12 tan 10 by tan 30, and then when you're done with that division, you're subtracting tan 10. You've got to have these parentheses. And since tangent opens a parenthesis, you actually need to have two here. Good. In fact, don't forget to close that one as well. So what do I get here? You might want to try this to confirm that you're typing it in properly. 12 tan 10 divided by parentheses. Tan 30, see, it opened it. You need to close it. Minus tan 10. Close the parentheses on tan 10. Close the parentheses on the denominator. And we get that x is 5.276319449. That's what x is, but I want to know h. Well, luckily, we have this equation right here. H equals x tan 30. I mean, you can certainly find using this one and do x plus 12 times tan 10. But this looks a little easier, so I'm going to take that x value and multiply by tangent of 30. And I get that h equals 3.046. And do we have units here? No, we do not. All right, so there's that one. One more? Sure. How about this one? X 10 plus 40 degrees and 50 degrees. And what do I want to know? I want to know x. X equals. I know, it feels like I don't have enough information. How many right triangles do you see? Good, me too. This is just a two-triangle problem. So here, opposite, adjacent, tangent 40 equals 10 over s. Okay? And here, tangent 50 equals opposite. Now, this is 10, this is x. I'm not multiplying them. I'm taking this and putting it together with this. That's addition. So opposite is 10 plus x over adjacent, which is s. Okay, so now what? How do we solve this? Well, let's add 10, by the way. If I multiply both sides by s, and then divide both sides by 10, 40, I can find out what s is. That's pretty fast. Okay, so 10 divided by 10, 40. So I get that s equals 11.91753593. Cool. Can I solve this equation for x? Because x is the thing I'm looking for. If I multiply both sides by s, then it gives me x plus 10. So I just need to subtract 10 from this value. So I'm going to take my s, I'm going to multiply by 10, 50, and then I'm going to subtract 10. And I get that x equals 4.203. Right? Nice. Okay, so we did some 2 triangle problems. Got more if you need more. Let's see. We did bearings, we did geometry. Ooh, how about this? Can you please write the equation for this function? Pi over 2, 7. 5 pi over 2, 1. And 9 pi over 2, 7. Please write the equation for that curve. Let's do it with these. Hey, what did you decide to go with? Please don't say sign. No, don't know. I don't know where this is yet, but I certainly don't know what x value these are at. It's really going to be hard to do sign. Please don't. Either negative cosine starts low, goes up, or positive cosine starts high, goes down. So I'm going to go with positive cosine. My d value is 7 plus 1 divided by 2, or 4. My a value is my high y minus my d, or it could be d minus my low y. Good. B, well, that's 2 pi over the period. And remember, we said period was ending x minus starting x. Well, there's my ending x. There's my starting x. 9 pi over 2 minus 1 pi over 2 is going to be 8 pi over 2, or 4 pi. Cool. So that's going to be 2 pi over 4 pi, or 1/2. So my b value is 1/2. And my c, remember c is the starting x. Now, be careful here. Yeah, starting x for what we saw. We saw positive cosine, starting high and going down. So that's where my graph starts. If you said this was negative cosine, then your graph starts here. And this is your c value. Right? Pay attention to that. So I end up then with y equals 3 cosine 1/2 x minus pi over 2 plus 4. And there's my equation. Okay. How about this one? Our graph. This is 1/3. This is 4/3. This is 7/3. 5. 5. 5. This point here is 5, 6, 3. And this point here is 11, 6, 7. Okay, so please write me the equation for that. Which family of curves? You know, if you start here, your C value is 11, 6, and you can make this positive cosine. If you start here, your C value is going to be 5, 6, and you're going to be doing negative cosine. But I thought to start here. And so this is my C value. But what function am I doing? Well, I'm starting on the midline and going down. So this is negative sine. Okay. So what's my D? D is 7 plus 3 divided by 2, or 5. Oh, right, that midline. And what about A? Well, A is going to be 7 minus 5, or 5 minus 3. There's that 3. This distance, 5 minus 3 is 2. Or this distance, 7 minus 5 is 2. And so we've got that. All we need now is E, which is 2 pi over the period. Please remember that the period is not 7/3 to 1/3. Some people do this on the test. They do this interval notation thing. Yeah, no. Period is one number. 7/3 minus 1/3. So what's that going to do? 7/3 minus 1/3 is 6/3, and 6/3 is 2. We have 2 pi over 2, so my B value is pi. So what equation can we write? Don't forget this is a negative sign. I have y equals -2 sine pi x minus 1/3 plus 5. And there we go. Okay. I think the last one I want to look at with you, but we have plenty more practice problems if you want, deals with the wheel of fortune. I have no idea if this TV show is still on or not. I have no idea even if you've ever heard of this show. But my grandparents, when I was in college, oh my gosh, they watched it every night. And it's a giant wheel, and people spin it. And, you know, there are different sort of prizes and pitfalls depending on where the spinning wheel lands. So let's say that, you know, when they're really competitive, they spin really fast because they think for some reason that that'll be better. But I'm sure it's also because it has to go at least once around. So they put all their might into it, and that's 22 revolutions per minute. Okay. The diameter is 7 feet. I'm sorry, the radius is 7 feet. And what I'd like to know is, 1, what's the angular velocity of the wheel? And 2, what's the linear velocity at a point on the wheel? And what I mean by that is here, at some point on the wheel where the radius is 7 feet. Okay? Well, what's my angular velocity? Well, you could say this is an angular velocity, but we know we really want radians per time unit. And so I'm going to have to convert this. Okay, well, that's 2 pi over 1 revolution. And so I get 44 pi radians per minute. And do you remember how we go from angular velocity to linear velocity? That's right. We had a formula, v equals r times omega. If I take the angular velocity and multiply by the radius, I'm going to get the linear velocity. So I'm just going to take 44 pi and multiply by the radius 7. 7 times 44. And we get 308 pi. And what are my units? Feet per minute. I can multiply that by pi. I would also accept 967.611 feet per minute. Okay, well, that's the kind of stuff I think you should be really ready for. Like I said, if you have questions, please let us know. If you want more practice problems, let us know. We'll hook you up with some. Have a great day, and I hope your assessment goes well. Take care.